Hello all. In today's lecture, we will see unit step function, which is also known as Heaviside function. In many real-life scenarios, we see the function does not start at t equal to 0. Instead, it starts after some time, say t equal to 5 seconds or 10 seconds. For example, a heater after turning on produces heat after some time, say t equal to 10 seconds. Or there are examples when the function act for some time interval. For example, an alarm ringing for t equal to 5 second to t equal to 10 second. For the rest time, it does not rings. So to represent such kind of piecewise functions, we take help of unit step function. Now to define unit step function, it is represented by ut minus a, and it is defined as ut minus a is equals to 0 when t is less than a and 1 when t is greater than or equal to a. This means the function becomes active only at t equal to a. Before that the function is inactive. Suppose there is a function ft which becomes active only after 2 seconds. So to represent this, we can write ft as ft into u t minus 2. Let's take one more example. Suppose there is a function ft which is 0 before time t equal to 5 seconds and which becomes 10 after t greater than 5 seconds. So this can be represented into unit step function as ft is equals to 10 u t minus 5. Let's see another example. So we have ft equals to t when t lies from 0 to 3 and t plus 4 when t is greater than equal to 3. So here the function changes its value at 2 points, one at 0 and one at 3. So we can write ft as t multiplied by unit step at 0 minus unit step at t equal to 3 plus t plus 4 unit step at 3. Now ut minus 0 will be 1 for t greater than 0, because you see the function ut minus 0 will be equal to 0 when t is less than 0 and 1 when t greater than equal to 0. So the function will become t 1 minus ut minus 3 plus t plus 4 ut minus 3. We can simplify this as t minus t into ut minus 3 plus t ut minus 3 plus 4 ut minus 3. This t ut minus 3 and t ut minus 3 get cancelled and the function becomes t plus 4 ut minus 3. So ft in terms of unit step function can be represented as t plus 4 ut minus 3. Let's see another example. We have ft equals to 2 when t lies from 0 to 1, t square by 2 when t lies from 1 to pi by 2, and cos t when t greater than pi by 2. So we have the function is changing the value at t equals to 0, t equals to 1 and t equal to pi by 2. So we can represent this into unit step function as 2 times unit step at 0 minus unit step at 1 plus t square by 2 unit step at t equal to 1 minus unit step at t equal to pi by 2 plus cos t unit step at pi by 2. Now this will become 1. So we can write 2 times 1 minus unit step t minus 1 plus t square by 2 unit step t minus 1 minus u t minus pi by 2 plus cos t u t minus pi by 2. If you simplify this further, you will get 2 plus t square by 2 minus 2 times ut minus 1 plus cos t minus, it will be t square by 2 here also, t square by 2 u t minus pi by 2. Next we will see the Laplace transform of unit step function. So the Laplace transform of unit step function ut minus a is equals to e to the power minus as upon s. From here, we will move to our second shifting theorem, which is also known as t-shifting. So it says that if the Laplace transform of function ft is equals to f of s, then the Laplace transform of function ft minus a into unit step function ut minus a is equals to e to the power minus as into fs. Let's see an example for this. So suppose we have to find the Laplace transform of t minus 2 into ut minus 2. So we know that the Laplace of function t is 1 upon s square. Therefore, Laplace of t minus 2 into ut minus 2 will become e to the power minus as, a is 2, into Laplace of f of t, that is 1 upon s square. Now here we have a question ft equals to t, where t lies from 0 to 2. We have to plot the graph of ft and represent this as unit step function. And also we have to find the Laplace of that function. Okay. So first we plot the graph of ft. So ft will be from 0 to 2. Its value is t. So the graph will be like this. Now we have to represent this into unit step function. So the function is changing its value at t equal to 2 and t equal to 0. So we can write ft as t ut minus 0 minus ut minus 2. Now ut minus 0 is equals to 1. So it will become t minus t ut minus 2. Now we have to find the Laplace transform of ft, that is Laplace transform of t minus t into ut minus 2. So Laplace of ft will be equals to Laplace transform of t minus Laplace transform of t into ut minus 2. Now we know that the Laplace transform of function ft minus a into ut minus a is equals to e to the power minus as into fs So in order to get this formula, we have to represent the function in this form, that is ut minus a into ft minus a. Here we have ut minus 2, so we have to represent t as t minus 2. In order to do that, we will write this function as Laplace of t minus 2 plus 2 ut minus 2. We add 2 and subtract 2. So it will become Laplace of t minus Laplace of t minus 2 ut minus 2 plus 2 ut minus 2. Now Laplace of t is 1 upon s square. Laplace of t minus 2 into ut minus 2 will be e to the power minus as. A is 2 into Laplace of t, that is 1 upon s square. And Laplace of 2 into ut minus 2 will be 2 times e to the power minus as upon s. Simplifying it, we will get 1 upon s square minus e to the power minus 2s upon s square minus 2 e to the power minus 2s upon s. Now let's see another question. We have ft equals to cos 2t, where t lies from 0 to pi. So this can be represented as cos 2t into unit step at t equal to 0 minus unit step at pi. This will become 1. So this is equals to cos 2t 1 minus ut minus pi. That is cos 2t minus cos 2t into ut minus pi. Now we need to get the Laplace transform of ft, which is equals to Laplace transform of cos 2t minus Laplace transform of cos 2t into ut minus pi. Laplace transform of cos 2t will be s upon s square plus a square, that is 4, minus Laplace transform of cos 2t into ut minus pi. So here, to get this Laplace, we have to represent cos 2t as cos 2t minus pi. So we will write this as cos 2t minus pi and plus pi times ut minus pi. This will become Laplace of cos 2t minus 2 pi plus 2 pi times ut minus pi. Now, if we add 2 pi to the angle in cos, the function remains the same. So it will become cos 2t minus pi times ut minus pi. Since cos theta plus 2 pi is equals to cos theta. Now for this, the Laplace become e to the power minus as, a is pi, times Laplace of cos 2t. Laplace of cos 2t will be s upon s square plus 4. This will be the answer. Let's see another question. Here we have an initial value problem. Y double dash plus y equals to 2t when t lies from 0 to 1 and 2 when t is greater than 1. And the initial conditions are y0 equals to 0 and y dash 0 equals to 0. So first we will solve the right hand side of the equation in terms of unit step function. So it will become 2t unit step at t equal to 0 minus unit step at t equal to 1 plus 2 times unit step at t equal to 1. Now unit step at t equal to 0 is 1. So it will be 2t minus 2t ut minus 1 plus 2 ut minus 1. And on the left side we have y double dash plus y. Now to solve this initial value problem, the first step is we need to take the Laplace transform on both the side. So it will become Laplace transform of y double dash plus Laplace transform of y equals to Laplace transform of 2t minus Laplace transform of 2t into ut minus 1 plus Laplace transform of 2ut minus 1. Now let's solve the right hand side first. So Laplace of 2t will be 2 upon s square. Laplace of 2t ut minus 1. To solve this, we have to replace t with t minus 1. So we can write this as 2 times t minus 1 plus 1 into ut minus 1 plus Laplace of 2 ut minus 1. This is equals to 2 upon s square minus Laplace of 2 t minus 1 u t minus 1 plus 2 ut minus 1 and plus Laplace of 2 ut minus 1. Now this Laplace of 2 ut minus 1 and 2 ut minus 1 cancel each other. So we will get 2 upon s square minus Laplace of 2 t minus 1 into u t minus 1. This will become 2 upon s square minus 2 upon s square into e to the power. On the left side, we have Laplace of y double dash and Laplace of y. This will become Laplace of y double dash is s square into Laplace of y minus s into y0 minus y dash 0 and Laplace of y is capital Y. This will become y of 0 is 0, y dash 0 is also 0. So it will become s square y plus y equals to 2 upon s square minus 2 into e to the power minus s upon s square. This becomes y times s square plus 1 equals to 2 upon s square minus 2 upon s square into e to the power minus s. So capital Y, that is y as a function of s, will become 2 upon s square into s square plus 1 minus 2 upon s square into s square plus 1 into e to the power minus s. Now from y we have to get y as a function of t, so we will take Laplace inverse on both the side. So y will be equal to Laplace inverse of this term minus Laplace inverse of this term. Now, to find the Laplace inverse of this term, we have to represent this as partial fraction. Let's do that. So 2 upon s square into s square plus 1 can be written in form of partial fraction as as plus b upon s square plus cs plus d upon s square plus 1. This can be simplified as as cube plus as plus bs square plus b plus cs cube plus ds square upon s square into s square plus 1. Now we just have to compare the coefficients. So the coefficient of s cube is 0 on both the side. So a and c sums up to 0. Then coefficient of s is also 0. So a is 0. Then coefficient of s square is 0. So b and d sums up to 0. And the constant term is 2. So b alone will be equal to 2. From this, we will get a equals to 0, b equals to 2, c equals to 0, and d equals to minus 2. We will substitute these values in our equation. So we will get 2 upon s square plus 1 equals to as plus b times s square, that is 2 upon s square, plus cs plus d upon s square plus 1, that is minus 2 upon s square plus 1. Now the Laplace inverse of this term will become Laplace inverse of this plus Laplace inverse of this. Laplace inverse of 2 upon s square will be 2t, and Laplace inverse of 2 upon s square plus 1 will be 2 sine t. So this is the solution of the first part. For the second part, we have Laplace inverse of 2 upon s square into s square plus 1 multiplied by e to the power minus as. A is 1. That is, we have Laplace inverse of 2 upon s square into s square plus 1 into e to the power minus as. So for this term, since e to the power minus as is multiplied, the solution will be similar to first, only time will be shifted. So it will be 2t minus a is 1, minus 2 sine t minus 1 multiplied by u t minus 1. So this will be the solution of second part. And y will become Laplace inverse of first part minus Laplace inverse of second part. So our y will be equal to 2t minus 2 sine t minus 2t minus 1 minus 2 sine t minus 1 multiplied by u t minus 1. Now, we have two conditions based on ut minus 1. So ut minus 1 is equals to 0 when t is less than 1 and 1 when t is greater than equal to 1. So for the first part, we can write y as for t less than 1, y will be 2t minus 2 sine t, and the remaining term will become 0 because ut minus 1 is 0. And for t greater than 1, we have y equals to 2t minus 2 sine t minus 2t minus 1 minus 2 sine t minus 1. This will become 2t minus 2 sine t minus 2t plus 2 minus 2 sine t minus 1. This 2t cancel and it will become 2 minus 2 sine t minus 2 sine t minus 1. This will be plus because minus minus will become plus. So here we will get plus plus. So the final solution we can write as 2t minus 2 sine t when t is less than 1 and greater than 0, since in our question t is starting from 0. And second part is 2 minus 2 sine t plus 2 sine t minus 1 when t is greater than 1. This will be the final solution.